Hi everybody, Denny here from ColdQuanta. Welcome to 3 Minutes of Quantum Computing. Last week we ran our StarBattle QUBO on the Mukai simulator and got the correct answer to the puzzle. This week we'll transform our problem into an Ising model so that we can use Qiskit, the quantum programming API from IBM. Our target is Qiskit's implementation of QAOA, the Quantum Approximate Optimization Algorithm, described in this 2014 paper by Eddie Fari. Ising models were developed by physicists in the 1920s as a simple model of magnetism. Since then, many variations on the basic Ising model have been studied. The one that we'll use here is also called a spin glass. For our purposes, the real difference between a QUBO and an Ising model is the set of values taken by the variables. QUBO variables can be 0 or 1. Ising model variables, which are often called spins, are +1 or -1. We can translate between QUBO variables and Ising spins with a simple equation. Different communities use different conventions for this translation. We'll use the one on the left. Converting to an Ising model is the first step. That just means for every variable x in our QUBO, we'll replace it with 1 minus s over 2. Rather than doing this by hand, SymPy can do it for us and then simplify the result. I've written a utility function for this, which I'm using in this little program that reads in the SymPy QUBO, converts it to an Ising model, and prints it out. The second step is to express the Ising model as an operator that we can pass to Qiskit's QAOA constructor. I've written a utility function for that also, which you'll see me calling in the complete program in just a moment. Our original StarBattle puzzle was an 8x8 grid. That means 64 variables. The only gate model quantum computer big enough to run that problem today is an IBM Hummingbird, which has 65 qubits arranged in a layout like this. We don't have access to that, so I'm going to run a smaller StarBattle problem on the Qiskit simulator instead. Here it is, and here is its solution. It's a 4x4 grid, so that means 16 variables, which is small enough so that we can use the Chasm Simulator built into Qiskit. Here's the complete program, which reads the SymPy QUBO for the 4x4 StarBattle puzzle from a pickle file, converts it to an Ising model, and then creates a Hamiltonian operator from the Ising model. After all this work, running QAOA is easy. Since QAOA combines classical search with quantum circuits, we provide a classical optimizer, which is Cobilla. We also specify the parameter p. We'll talk about some of these details next week. Execution on my laptop takes around 4 minutes. Here's the output file, which lists the spins, the complete Ising model, and the response object from running QAOA. There's a lot to talk about here, much of which I've skipped over, so we'll come back next week and fill in some details. That's it for today. Thanks for watching. Bye, everybody.